Okay, so in this video, I'm going to go over some more examples of how we can use the substitution method to integrate some not so simple integrals. So let's look at this first one. Here we have the integral of x cubed times the cosine of x to the fourth plus 2 dx. So it's not obvious what the antiderivative is going to be. So what we're going to do is make u the x to the fourth plus 2. Now you're like, why did I choose that? And how did I know to choose that? Well, I've been doing this for like a couple hundred years, so I've had a lot of practice. But the idea is to look to see if you can find the derivative of an expression within the integrand. So if we take the derivative of u with respect to x, with du dx, that would leave us with 4x cubed. And I'm going to rewrite this as du equals 4x cubed dx, and then multiply both sides by dx. Now we don't quite have 4x cubed, but we have x cubed. And so what we do here is just divide each side by 4. And then what we get is that 1/4 du is equal to x cubed dx. And that's perfectly okay to put in there, because then we just make 1/4 du times the cosine of u. So then this can be rewritten as the integral of 1/4 times the cosine of u du. So remember that we have the 1/4 du as right here. Don't worry, don't let the order like throw you off. It's just like multiplying across. So even though x cubed is at the beginning and dx is at the end, that's perfectly fine. So that's how we get the 1/4 cosine of u du as our expression. Then we just find the antiderivative of this with respect to u. And that would just be 1/4 times the sine of u plus c, of course. And then we resubstitute our expression for u into our answer. And let me try to write this. I'll probably have to write this up here. I want to go into the space of the next problem. I'm going to move my ducky. And your answer will be 1/4 times the sine of x to the fourth plus 2 plus c. All right, let's go through the next one. Here we have the square root of 2x plus 1 dx. And so again, let's think about what we can make the u. Let's make the u equal to 2x plus 1. And again, when you're not, when you're not sure, and obviously since you guys are probably pretty new to this, just experiment. Just try to see what would happen. So if you make u to 2x dx, du would be 2 dx. And then what you see is that you have dx. So we just need that 2. And what we can do is just divide both sides by 2. And we'll get that 1/2 du equals dx. And there we go. So then we can rewrite this as the integral of 1/2 times the square root of u du. Because again, we have that dx there as the 1/2 du. And then this is easy to integrate. We just find, or let's rewrite this as u to the 1/2. So 1/2 times u to the 1/2 du. And then just use the anti-power rule. We'll add 1 to the exponent. So we'll have 1/2 u to the 3/2 divided by 3/2 plus our constant c. Simplifying this, we'll get 1/3 u to the 3/2 plus c. Resubstituting 2x plus 1 in for u. Then our final answer will be 1/3 times 2x plus 1 to the 3/2 plus c. All right, let's look at the next one. We got the integral of x over the square root of 1 minus 4x squared dx. Okay, so we're stepping it up. So what we're going to do is we're going to make the u equal to the 1 minus 4x squared. Then our du will be negative 8x dx. And we don't have negative 8x, but we have x. And all we need to do to make this into x is divide both sides by negative 8. And so we get negative 1/8 du is equal to x dx. So now we're ready to rewrite this in terms of u, because we have x dx as negative 1/8 du. So this will be equal to let me break this up so it's a little easier to see. 1 over the square root of u multiplied by that x dx, which is going to be negative 1/8 du. I'm not sure if that makes it a little easier or more confusing, but in either case, you can just factor out that negative 1/8, and you just get negative 1/8 times the integral of 1 over the square root of u, and that's just like the same as u to the negative 1/2 du. Because, when it's u to the 1/2 in the denominator, bringing it up, you're going to make it negative. Now, this is a simple integral to integrate. We just add 1 to the exponent. So you have negative 1/8 times u to the 1/2. And we're going to divide by 1/2 and add our constant. Let's simplify this next. We'll get this is equal to negative 1/4 u to the 1/2 plus c. Resubstituting the 1 minus 4x squared for u. And our final answer will be negative 1/4 times 1 minus 4x squared to the 1/2 plus c. Or you can rewrite negative 1/4 times the square root of 1 minus 4x squared plus c. Okay, let's look at D. And this one can be a little misleading because it could seem very simple, but then it can end up be more confusing than you realize. But what we're going to do is make u the 5x. If we make u 5x, then du will be 5 dx. And that's exactly what we have left over. We have our 5 dx right there. So this is simply the integral of the cosine of u du. You don't need to divide or multiply or do anything like that because the 5 dx is actually in the integral. We find the antiderivative of the cosine of u, which will be the sine of u plus c. And we rewrite this in terms of x. So we substitute 5x for u. Sine of 5x plus c will be then our final answer. All right, for e, we got the integral of the cosine squared of x times the sine of x dx. Okay, so this is where we're going to have to be, kind of experiment. Well, usually, I've done this before, obviously, so I know what the correct answer is. But again, if it's your first time, dealing with using u substitution, don't feel like you have to catch on to this right away. It takes practice, and it's just going to be part of the process. And eventually, you'll see the pattern like that. Anyways, we're going to make the u the cosine of x. And that's then going to mean that du will be the negative sine of x dx. And we kind of have that, but we have positive sign of x dx. So then we're going to divide both by -1 or multiply by -1. And then so we have negative du equals the sine of x dx. And that's what we have left over here. And so what we're going to have is the integral. Remember, we made u the cosine of x. So we're going to have actually u squared because we have the cosine squared of x, which is, the cosine of x times the cosine of x. So we have u squared times a negative du. So negative du, we'll bring the negative symbol on the outside. So we just have the negative integral of u squared du. And then from here, this is actually a very simple integral to integrate. We just add 1 to the exponent. So u to the 3 divided by 3 plus c. Rewrite our answer in terms of x. So we're going to resubstitute cosine of x for u. And we're going to get the negative cosine of x all to the third power over 3 plus c. Oh. Plus c is our final answer. All right, let's go through one more. All right, this is a good one. So here we're going to make the u the 1 plus x squared. And that means du will be 2x dx. And what we're going to actually do, even though we have x to the 5th there, we're going to just make this into an x. So we're going to divide by 2. So we'll have 1/2 du equals x dx for now, because we still need to figure out how we get that x to the 5th. So what we're going to do here is, do a little math magic or a little algebra trick. And we're going to rewrite this as u minus 1 is equal to x squared. When you take away 1 from each side, okay, u minus 1 equals x squared, right? And we're going to square this because remember, we have only an x dx, and we need to find it x to the 5th. So if we can produce an x times an x to the 4th, we'll get an x to the 5th. So we're going to square this and square that. And that's going to mean that we're going to get u minus 1 squared as x to the 4th. Now let me try to break this down a little bit more. Let me rewrite this down here. So in other words, we're looking at this as the square root of 1 plus x squared multiplied by x multiplied by x to the 4th dx, because x times x to the 4th is x to the 5th. And see that x to the 4th then becomes this. And that u is under here. And that 1/2 du is that x dx. So then now we can rewrite this as the integral of, again, we're going to make this the square root of u, that x dx, that'll be our 1/2 du. I know it's going to look weird. I just want to put it that way, just so, well, actually, let me just put that du at the end afterwards, because that's going to be misleading. Let's put that du like over here. And then that x to the 4th, that'll be the u minus 1 squared. Now, not u minus 1 to the 4th, u minus 1 squared is what I meant to put. So now we can actually just expand this and, rewrite our integral in terms of just u. So this will be 1/2, factoring out the 1/2 and putting it as a leading coefficient. We're gonna have 1/2 times u to the 1/2 power, u minus 1 squared. That'll be u squared minus u times minus 2u plus 1 du. And I'm gonna multiply then each of these by u to the 1/2. And let me grab an extra sheet of paper so I don't cram all the writing in there. Improvising. So then what we get next is 1/2 times the integral of u to the 2 times 1/2, so to the u to the 5/2, adding the exponents, minus 2u to the 3/2, plus u to the 1/2 du. And then from here, this is actually an easy integral to integrate because we can just use the reverse power rule. So we have 1/2 times adding 1 to the exponent, u to the 7/2 over 7/2, minus 2 times u to the adding 1 to the 3/2, u to the 5/2 over 5/2, plus adding 1 again to the 1/2, u to 3/2 over 3/2 plus c. And let me just clean this up a little bit. So we get 1/2. It becomes, those 2's cancel, it becomes 1/7 u to the 7/2. The 2, those 2's cancel again. So minus 1/5. Or no, minus 2/5 u to the 5/2 plus a 1/3 u to the 3/2 plus c. And now we just can rewrite this in terms of x by substituting our 1 plus x squared wherever we see a u. And so our final answer will be 1/7 times 1 plus x squared to the 7/2 power minus 2/5 times 1 plus x squared to the 5/2 power plus 1/3 times 1 plus x squared to the 3/2 power plus c. Whoa. And there you go. That's all there is to it.